go. So this is a trinomial. The way we factor our trinomials is we do a times b. A times b is the key. So I'm going to do 10 times -2, and that's -20. And I'm going to factor tree that. You can absolutely do that factor tree by hand or in the calculator. So I like to start out here. 1, 2, 3, 4. And if you're using Desmos, we've had students who've done well in this unit using Desmos for every step. We've had students not touch it. So it's just up to you. You can do all of the division on Desmos and going. You just have to put it in, right?
I thought that was 3.
Divide by 2, 20, divided by 3. Doesn't go in evenly, so it doesn't go in our factor tree. So 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5. There's our factor tree. Which one of those is going to give us -1? Yeah, awesome, 4 and 5. And to get a -1, I'm going to do +4 and -5. That would be it would be a +1 in the middle and give up a +5. I'm going to bring down my 10x squared plus 4x minus 5x minus 2. We split that middle term into 2 so that we can do factor by grouping. This is called factor by grouping. But what factor by grouping is just GCF. My first 2 terms, I can take out an x. If you're not sure what number to take out as well, use GCF in the calculator. Do GCF 10, what are we doing? 10 and 4. Let it help you. Don't get stuck because you're trying to do the math in your head. So we can take out a 2. You can always take out an x from the first 2 when you're doing a trinomial. Okay? 10 divided by 2 is what we're going to do first after we put this 2x on the outside. 10 divided by 2 is 5. X squared divided by x is x. Plus in the middle. 4 divided by 2 is 2. And the x is canceled. With this negative down here, that whatever sign is in the middle, whether it's positive or negative, that sign needs to come down. Now, 5 and 2 don't have anything in common. If you tried to GCF over here 5 and 2, you get 1. And that's actually what you need out front there. You need that -1. What you're doing here is dividing by -1. It's going to flip those signs. The signs are the trickiest part. -5 divided by -1 is +5, and it does an x. -2 divided by -1 is +2. And then we're going to write our final answer. 2x minus 1 times 5x plus 2. And that's your final answer. Done. That's factoring a trinomial. Here's the thing. If you don't have these middle steps in here, this step, and this step, that's the only way I've taught this. That's the only way I've taught this. So if you don't have those middle steps tomorrow, and you have the right answer, I'm going to ask some follow-up questions. Tell me how you did that. Tell me how you did that in words, or give me some kind of explanation. There are ways to jump those steps. They're harder than doing this process. They're more time-consuming than doing this process. And so that's why we teach this process. All right, show us all your steps. Difference of squares. So we're telling you this is a difference of squares. That's awfully nice of us. We're telling you that these are perfect squares. So difference of squares, your pattern always looks like this. 1 plus, 1 minus. And the math that you do to each term is square root. So if you don't know the square root of 121 off the top of your head, you can do it in the calculator. It's 11. So x squared is x times x. 121 is 11 times 11. Where you put the terms matters. So since the x squared is in front, you have to put the x's in front, and the 11s have to go behind the signs. I'm worried that you guys aren't practicing along with me. I hope that you take advantage of the retake. It's important stuff. So here on number 3, this is a GCF problem. So we're telling you all you do here is take out a greatest common factor. I only have one x, so I can't take out an x. So we can go back here and put in 55 and 75. It is absolutely a fact. We're going to take out a 5. And then if you want, just go ahead, learn your Desmos, you know you're going to need to divide. So 55 divided by 5, 75 divided by 5. There are your leftovers. The 11 is going to have an x with it. Make sure you're writing your GCF out front. That's a really important piece. Write your GCF out front. I had a lot of people write it down here and then not write it out front. If that's how you type it in on the OST, you're going to lose all the points. But you're going to have done the math right. When I ask you to use the circuit property to check your work, you're doing this now. And show it. 5 times 11 is 55. It has an x. Oh, I'm sorry. That should be a 15. Here we go. 5 times 15 is 75, and that's where we came back to. Number 4. We're doing A times C is the key when we see a trinomial. 2 times 8 is 16. We need two numbers that multiply to positive 16 and add to negative 10. So if I'm multiplying to a positive, I can do that by doing positive times positive or negative times negative. Since I'm adding to a negative, I'm going to need two negatives. And I think that's a good one. It's a good thing to recognize first. Yeah, -2, -8. Awesome. Does 3 go in to 16? Nope. Does 4? Nope. And then since -4 and -4 are there, we've wrapped around. We've used all the factors. Wait, how am I going to get -10? Yeah, -2 plus -8. And now we're going to do the trinomial. So I'm going to split my -10x into -2x minus 8x. I'm going to bring the 2x squared down in front. I'm going to bring the 8 behind. That order doesn't matter, but this order is really nice for seeing the GCF. If you look at this 2x squared and 2x, what do they have in common? Oh, they have their 2x in common. This is a nice one to kind of read out loud to yourself because you can hear the common factors. The 2's cancel. X squared divided by x is an x. The 2's cancel and the x's cancel. We have to have that 1 there as a placeholder. Again, you guys are all at different places. Some of you just need to clean up some signs or earn some points tomorrow. Some of you need to work without your review. Some of you need to earn back a lot of points on everything. And all of those things take practice. All right, so I have this minus in the middle, and here's where one of those tricky sign things happens. 8x and 8 have 8 in common, but I have that negative there. So when I write this division out, I need to be dividing by negative 8, not just 8. So, and that's going to switch these signs. Negative 8x divided by negative 8 is just x. 8 divided by negative 8 is negative 1. And now these match. And that's your factored form.
Yeah. Okay, that one wrong.
All right. 5 is a GCF problem.
24.
What can I take out? I can take out a 3. I totally agree. What else can I can take out an x. Absolutely. I can take out a 3 and an x. Remember, if you're writing that below as like scrapwork and as the GCF, then you need to be writing it on the outside as well. And now we divide. 9 divided by 3 is 3. X squared divided by x is x. 3 divided by 3 is 1. Cancel, cancel. Remember, if you see cancel, cancel, that's a 1. That's your final form. This isn't a bad one to like just even imagine. Okay, that's 3 times 3 is 9. X times x is x squared. 3 times 1 is 3. X, no x, x. Did I get back to the beginning? Yes. Okay. It's not a bad one to do that on. It's kind of helpful sometimes to do that multiplication and check your work. Again, we're working towards a couple of things in here, and one of those is getting a little more than half, is what it's been the last couple of years, of the problems right on the OSC. A little more than half. But it's not just right, it's perfect. It's perfect. So you have to, this has to be perfect for you to get the points. All right, trinomial. When we're doing trinomials, we're doing A times B. I see some of you are working ahead. I really appreciate that. That is the right thing to do. Is a pretty good factor tree. There are a lot of factors, but they're factors that we've done the factor tree for 24 quite a lot. If you're having trouble remembering what am I doing the factor tree for, this is what I do a lot. I'm multiplying to 24, I'm adding to negative 11. Label it for yourself. I think it's really helpful just writing those words will reinforce it for you. So 24, 1 and 24, 2 and 12, 5 doesn't go in. If we're multiplying to a positive, then we're adding to a negative over here, then we need 2 negatives. So we are going to use negative 3 and negative 8. I love you guys using the whiteboards because those of you who are really using today well, like I can see it. I love it. Thank you. That's like the marker colors. Cut it in half. The order that I did this in, you could have put the 8 first. If you would have put the negative 8 first, you would have been able to take that 2 out. But since I did 2 and 3, 2 and 3 don't have any numbers in common. So I can only take out an x. 2x squared divided by x is 2x. 3x divided by x, those x's cancel. I can bring down this 8. I'm sorry, not the 8, the negative. And just to remind you, if you are struggling with these GCFs, you can put 8 and 12 in. You're absolutely right, you can too. The GCF of 8 and 12 is absolutely 4. But if that's not something you're doing in your head, that's okay. You gotta get it one way or another. We're taking out a 4 from those last two terms. And it's not a positive 4. When we're dividing here, we're dividing by a negative 4. Because you have this negative in the middle.
Oh, yeah.
Also, dividing by that negative 4 is going to switch this sign, so your signs will match in your parentheses. So negative 8 divided by negative 4 is positive 2. 12 divided by a negative 4 is a negative 3, and now those match. If you made that a positive 4, they wouldn't match, so you wouldn't be able to pull them together. Okay.
Did I do this right?
You did?
That's number 6.
Yeah, x minus 4, 2x minus 3. That was lovely.
Oh, nicely done.
That was number 6. Almost to the front, and then the back only has multiple quick problems on it. 3 more. 7 is another trinomial. Sometimes they look more confusing when the numbers are tiny. You're so used to making a big factor tree for something like 24. You come here and you're like, oh my goodness, multiply to 2. What numbers multiply to 2? Yeah, 2 and 1, or 1 and 2, whatever order. That's it. 7, and all your prime numbers have a factor tree like that. 1, 3, 7, 5. Your factor tree is tiny. So 1 and 2 has to be it. Everything is positive here. So we're adding to 3. Again, the way we split the middle, we always end up with the same thing. I had 3 x's up here, and now I just broke it up into 1 x's and 2 x's. Everything's equivalent along the way. My first 2 terms always have x in common.
There's too many ones.
I just feel like that sometimes too. That's why sometimes I won't break that 1 in front of the x. So then I have 2x plus 2, so I have 2 in common there that I'm going to divide out. There's your work, looks really nice. X plus 2, x plus 1. Now this problem asks you to double distribute to check. So here's what that stuff looks like. X times x is what? Every time. X times 1 is 1x. 2 times x is 2x. 2 times 1 is 2. Hey, look at this step right here that I just wrote in that box, and this step that's right for like our first step. We are doing this by double distributing and factoring. It's like literally forwards and backwards. Yeah, there. So then this right here is 3x. That's all I was looking for. I'm looking for enough double distributing here that you're checking your work, and that you could, like, if this was a problem you were given on the OSC, hey, multiply. You're showing me here I can multiply it and I'd be able to. Okay? Just double check your work, do the double distribute. Alright, number 8. Here we're going to factor treat negative 14. Again, I'm going to do 1 times negative 14 to be negative 14. My pairs, I'm looking for 2 numbers that multiply to negative 14 and add to 5. Awesome. 1 and 14, 2 and 7. Those are the only pairs. And Savannah said I need negative 2 and positive 7 to get 5. Negative 2x plus 7x. I'm going to bring down that 14. I'm going to bring down the x squared. Do I like the order of this one? I like the order that just happened here. What can I take out of my first two? X. What can I take out of my next two? 2 to the left when I divide away by 7.
Oh, I thought you had.
No, I know where you are if you're telling me what's left. All right, 9 is a GCF. 4 and 24 have 4 in common, so I'm going to bring out a 4. What else? I have n squared and a, and then n. What can I take?
4.
I can take out 4 and? Yeah, they both have n in common, so I'm going to divide away the 4n. And I, like this one, I know I kind of stopped writing the divide bars, but this one I definitely would. And I'm even going to color code up here because this is messy. 4 divided by 4 gone. N squared divided by n. How many n's are going to be left here? Yeah, n to the first. Remember, the math that we're doing is this. We're subtracting the exponents. I also am going to have that a left. So I have just n and a. You can write a 1 in front of there if you would like. I'm going to put a subtract in between. 24 divided by 4 is 6. N divided by n cancels. Yep, it's minus 6. Absolutely. Beautiful. Awesome.
I'm going back to.
Yep. Flip over.
What I'm doing.
All right, multiple choice.
Okay, so the directions say we've been given factor form, and what we have to do is pick which one is equivalent. So this is factor form. Here are the trinomials that could match. So one option would be to double distribute.
Oh, yeah.
Okay, so I'm going to go ahead and rewrite 2x minus 3 times 3x plus 5, just to give myself a little bit more room. And now we're going to double distribute. We'll start with 2x and we'll multiply 2x by 3x. 2x times 3x is 6x squared. So I'm going to stop for a second. Can you get rid of any of those options right now? Which ones don't match 6x squared to start with? Yeah, A and C. So that's a really good test-taking strategy. Now I'm going to keep going. So 2x times 5 is a positive 10x. Now, I have to keep going. I can't start looking for 10x up there. I'm going to take negative 3 and multiply negative 3 times 3x. That's negative 9x. And then negative 3 times positive 5. And that's negative 15. Okay, so just as a reminder, we've got 6x squared to start. 6x squared starts for both of those options. And negative 15 is on the end. We only have one option with a negative 15. And that's option D. And now I just want to point out, if we combine these two like terms here in the middle, 10x minus 9x is 1x. And that does match. This is what our trinomial will look like. And it matches letter D. Okay, so I just want to show you how you can use Desmos to make sure that you are 100% accurate, or if you wanted to use Desmos to help with everything. So we'll put in that factored form first at 2x minus 3 times 3x plus 5. 2x minus 3 times 6 plus 5. Right, does that match? Okay, thank you. All right, and then the other one that we're going to put in, so here is our quadratic for factor form. And what we're going to do is we're going to put in the other letter D that we found should be equivalent to this factored form. So 6x squared plus x minus 15, we're going to put that one into Desmos as well. And if you notice, the quadratics match. So the graphs for both factor form and the trinomial is completely the same because they are the same. It's the same quadratic. One is in standard form, one is in factor form. So it's really important. We've had some students say, well, can't we just use Desmos? Couldn't we just use Desmos here to see if that matched? Yes, you could. Absolutely could. If you didn't want to do any of this math, any of this double distributing, and just put this in Desmos, that doesn't match, cross it off. Put this in Desmos, that doesn't match, cross it off. Put B in Desmos, that doesn't match, cross it off. Here's the thing, if we went in that order, A, B, C, we would have to put this last equation in Desmos, which can take some time off the clock. This does not make sense?
No, not.
Oh. Okay, I'm going to keep going. All right, so if x minus 13 is a factor of x squared minus 9x minus 52, then the other factor is. Okay, so what this is saying is x minus 13 is one of the factors of this trinomial. If we factored out, if we did a times c is the key, we would have to factor out negative 52. That's not fun. So let's use Desmos to help us through this. We know that x minus 13 is going to be one of these factors. We just have to figure out what's going to go in that other set of parentheses. But we do know what our standard form is. So that's what I'm going to put in over here first. X squared minus 9x minus 52. Okay, so here's standard form. Now the other thing that we need to do is put part of our factored form in. So we said x minus 13 is one of those. Where's x minus 13? We just have to find the other one. So one of those options is x plus 4. Let's try that one. Does that one match? It sure does. I did no math. I did no double distributing. I did no factoring of negative 52. It matches. So your answer is A. Now I just want to show you how we could check. If we went with x plus 5, you can see how that does not match. So x minus 13 and x plus 5 would not be your factored form of x squared minus 9x minus 52. That would not match. Okay. Let's keep going. We're going to factor completely here. So the first thing that we're going to need to check with is GCF. Can we pull a GCF out? We can. What can we divide away? We can divide the 3 away. Can we divide any x's away? No x's. No, so just a 3. If we take a 3 out, here's our, and then I'm going to have x squared left inside. And 27 divided by 3? Negative 9. Good. What do you guys notice about x squared and negative 9? What's perfect about those numbers inside the parentheses? Yes, they are perfect squares. So that's one thing that's kind of tricky about this one. Is this is a 2-in-1. So we have to GCF and do difference of squares with this problem. This one might be a great one for Desmos. So now I'm going to split x squared minus 9 into two sets of parentheses. I'm going to keep that 3 out front. And what am I going to split x squared into? X and x. And what am I going to split 9 into? 3 and 3. So here's my minus 3, and here's my plus 3. Does that match any of your options? Yep, it sure does. Letter C.
Now, if you put this one in Desmos, the thing that happens is that there are two that are correct. And so you have to pick the one that's fully factored. And that makes that a little bit trickier than kind of normal.
So if we look back at our options over here, we do have to be careful because there are two options over here that could work. So we just have to make sure we pick the one that's factored completely. We have to make sure that we've got that 3 on the outside and we have our x's split. So this is a great one to practice difference of squares.
And it's a really good example of something that you could see on the OSC because they are, again, they like to kind of get the most bang for their buck. They can see if you can do GCF and difference of squares by that one problem.
Okay, another one asking which one is equivalent to. So you can absolutely plug this into Desmos. Yep, and see if they match. So if we plug this into Desmos, all we're doing is looking to see which ones match. It also can take up a lot of time, especially if you're going in order here and your answer isn't down here until you get to letter D. So this is another one that we could factor using split the middle, and we can also just plug into Desmos. So I'm going to go ahead and factor 3 times negative 20 is negative 60. Negative 60 is kind of a big factor tree. Did anyone find which two numbers we would use to get to 7x? So you said 5 and 12. And then which one would have to be negative? Negative 5 and positive 12. So I'm just jumping up forward just a little bit, save us a little bit of time. Negative 5 and positive 12 will give us positive 7.
Oh, yes.
Do you see the
Yeah, I see that.
Oh, okay.
6 and 7.
Yep. 3 and 20 is 60. Okay, I'm going to go ahead and split 7x into negative 5x and positive 12x. And we are going to take those and we'll divide something away. We'll divide out an x. We can't divide a 3 or a 5 away at all. We'll just pull that x out. When we divide 3x squared divided by x, we're left with 3x here. And 5x divided by x, we're left with a negative 5.
Okay, you can get rid of some options right now. Do you see that 3x minus 5 in parentheses there? You can go back up and we might be down to one answer.
There you go.
Just make sure, I would finish it, especially if I was trying to make sure everything is perfect, make sure my signs are perfect, but you're so close, you feel really good about where you are with this one.
Now, once we know that that other set of parentheses needs to be 3x minus 5, so one of our factors needs to be 3x minus 5. Let's go ahead and let's finish. We're going to divide something away from 12 and 20, but we know 3x minus 5 needs to be here. So what would I divide away from 12 to get 3? I would divide a 4 away. Yeah. And that ends up being a positive 4. And there's my leftovers with 3x minus 5 inside. X plus 4 is my other set of parentheses. There's my answer.
Again, you could also use Desmos. You would just have to, like, if you're going ABC, it would be the third one that you enter. when you're entering in Desmos, you just gotta make sure you're being very careful.
Yes, good question. So when you're asked to show your work or how did you find your answer, then you would just write in use Desmos.
Or you could write like guess and check in Desmos. And you could like say like A, no, B,